All right, everyone, what is better, R Studio or Python? I almost said Panda. I think that's the place you eat. Python for basic linear modeling. Now, if you've had me in class, you know I prefer R Studio, particularly for the advanced models, etc. This is in the IDE, as you can see up here, Spyder. And the language is Python. So what we're going to do is we're going to do a little modeling, just basic linear modeling, what I've done a number of times with the ice cream data set, but this is different in Python. My overall argument is this is a very nice IDE, kind of user-friendly interface for Python. Spyder, it's used essentially for statistics, more scientific stuff. I still stick to the argument that for high-level data science, statistics, everything from time series, logistic regression, etc., RStudio was made by statisticians for statistics, whereas this is not. But if you are interested in learning a bit about Python, I do use it. So this is what we can do. I've already done this a number of times, but the import's a little different than you have in RStudio. You need the pandas. So it's simple import space pandas, right? And then it has the same logic as RStudio pops up here. You can hit it twice if you want. And then as PD, it's already written up there. But you got to go up here and run it. So you see here, it comes up here. So then we have this stats model formula, API as SMF. I'm not going to sit here and explain all of this to you, but these are the basics you need. And just this keyword here for regular linear model. Now, as you can see in RStudio, you don't need to do this for basic linear modeling. It seems like there's way more steps in Python relative to RStudio because I really think this was not made by statisticians. So here we go. And now we run it up here. So it's got a nice interface. I'm going to show you some really cool stuff with it. And now this is one of the things, we have to import OS because we're doing what you call the OLS model. That's basic linear regression. We're not going to control for outliers or anything like that. It's a very popular form, whether it's the best or not. That's a debatable thing. So we downloaded the most important packages for now. But the thing I'm not too crazy about with Python, at least, is you have to essentially, if you notice up here, I've done the mice, I did the affairs data set and other things. This is a bit weird. So if you take this, like say, for example, I'm going to copy and paste it and show you down here what you have to do in order to get and unless there's other ways, and I welcome those that feedback, you have to go and copy and paste the file in here and put R here, I don't know why, and call it something which is equal. So this is getting the data set. We'll call it something else like me like ice cream. All right. Now we're going to go here. It's PD point, right? Little dot, read/CSV. People kind of like Python for this reason. It sounds more intuitive, like you're getting things out, etc. So we just go here at the end, or you can, I like doing that. Let's see what we got here. So it seems like, let's see if it came up here. It comes up over here. I kind of like, this is kind of cool. So you can just click it and then you can see it. Let me share that. And as you can see, I hope you can see, it has all these different colors, and I believe the darker, say blue, are higher levels. And it does something where the colors go by the different levels of the numbers. So you see here, 29 is a good looking idea. You can sit here, cons, income, price, temperature. It looks kind of nice. It's on its own. You can just upload it like that. I kind of like it. I think it is actually pretty good. The weird thing is I don't know what to share. Oh, here's Spyder share without that. So that's kind of cool. You can bring that up. And there are different things you can do with Python. So let me get out of there. One I like, I've been doing this all the time, is this. I won't even go into all these, but you can do this kind of descriptive statistics. So if you take, let me see where it is. I just copy and paste it up here. Paste. Here, this is a little different, but if you go, watch this, I'll call it me. See, it comes up here. It's called a variable me like ice cream. Descriptive statistic. And then here, let me change that because I had it called something else. It's kind of easy. So me like ice cream. Oops, I don't know why that says descriptive stats. Let's take a look at how it goes. So if you look it up here, me like ice cream, descriptive stats. Oh, it is. I call it descriptive. You can see, as I will do this, so you can definitely see it, that you have the mean of the cons, that's consumption, income, price, and temperature. Pretty nice, huh? So this is kind of popular, I'm sure, with data scientists who aren't doing the most advanced research. So that's pretty cool, and I think that that's one of the reasons why people, oh, you could just get the mean, the standard deviation, etc. Now we're going to run it like we would in our RStudio. It's a little different. So bear with me. We're going to call it something, right? Let's call it, what do you want to call it? Ice cream, ice hielo, put a little Spanish into that, equals. Now this is a little different. This is smf.ols. Now you still use the parentheses. It's very similar to RStudio, but you got to put it in parentheses, quotes, consumptions, dependent variable first, Tia tilde, temp, get out of that little enclosure, and then just put, what's the name of it? Me like ice cream. Me like ice cream is the data set. So here you go. So it's very similar to R's writing. That's why I think once you know RStudio, you could do Python, or once you know Python, you can do RStudio. Again, I still think Python is good, but RStudio, that is the statistical environment, RStudio, the user-friendly interface, is a little better when we start getting to higher level statistics. So right there, we're going to run it. And now it's a little different again than RStudio, obviously. We're going to print it out. Here it is. That's the what you do. You can see, and here I like, because it'll show you the different things you can do with it. But regardless, what's the name of it? It's Hielo. Oop. See, so it's right there. Hello, Hielo. And then dot summary down here. And then again, you always have to close it. So it has the same logic as the R language, which is pretty interesting. So let's run this. Oh, something happened with it. So I'm not doing it right. Look at that. Print. They like, but I do it all the time that as well in in the other one. So it doesn't really matter. Let's take a look at ice. Make sure I got this right since I haven't been using Python as much. So we do print. Oops. Yellow. Oh, yikes. Oh, it comes up on two. That's interesting. But it's H-E. My spelling is awful. There it is, variable. Oh, I see what happened. I have to do the point fit. Not used to that at all in R Studio, the added stuff here. So I did EALO. I had to go back smf.ols. That's the function. As you know, same thing, consumption temperature in parentheses, comma, me like ice cream. But then you have to do this fit. So now we're going to do print hielo. Yikes. Any mistake I made has nothing to do with Python. It has to do with me. All right, there you go. So this fit threw me off, and I like when I get thrown off because this is such a different language, although it's very similar. And if you're able to do R, you'll be able to do Python. Because remember, R, we do in R Studio, which is the user-friendly interface. This is Python using the user interface Spyder. So Spyder is probably the best. You can do it in others. I don't recommend it. PyCharm has been pretty good, but this is a good one. So we do get the print or yellow summary, right? OLS regression results. I like some of this because in the results, it specifically says OLS. It says dependent variable consumption. That is temperature is the independent variable, seeing if consumption moves. We have the model. We have very similar results as we would in R Studio, very high square, 0.6. I believe it is 0.7 a little. This does use the scientific notation here, which is pretty good. But here you see 0 for the temperature, which means it's very significant. It's under 0.05. We're not going to get into Durbin and Watson, but I like how they do show these things. And the skew, etc. So they give some good information here, but you can get that information in R Studio. You get the F statistic. That's not really, we're not going to use that here. We would in an ANOVA function, but that's a pretty good R squared. It is statistically significant. That's a very high T value. It's only, as we can see, a coefficient standard error is 0. That's, I mean, that's good for your model because that's the variability in your repeated sampling. And then you've got like the more practical value for every unit of temperature that increases. Ice cream consumption goes up 0.0031. We're getting similar results with Python that we would with R. This is Spyder. It's pretty cool. I've been fooling around with it and using it. Sometimes it gets clunky for me when I'm typing, as you can see, because I'm way more used to R Studio than I am with Python Spyder. But this is a pretty good model, and it is a pretty good user interface with the Python language. I still stick to R Studio, especially when we're doing more advanced modeling, but a lot of people like this. I see that there's a lot more steps in the Python language. I really think the reason why people use Python is because it's a general language. So people who are used to it, if you do data science, which sometimes is like an MBA, you're doing basic descriptive statistics, etc. But if you're doing time series, panel data like I do, really high level stuff, you might want to stick to R Studio, but Python, if you want to lose all the codes, can be good too. Thanks everyone for coming out and listening to my first Python video.